Okay, today we're going to be talking about directory services. We use LDAP as the case at this point because up until very recently we didn't have access to licenses for Windows Server, so we couldn't do Active Directory. But if you can do LDAP, you can handle Active Directory. They're just different implementations of the same concept. You'll be doing some in the labs on Active Directory, but we just talk about LDAP and how that fits in. So, directory services. What we're going to be looking at is there, blah, 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 what is LDAP, etc. But the first thing we just need to understand is a bit of history on it. LDAP was derived or created as a front end to something called X500. X500 is a directory service set of protocols that does lots and lots of things. And the thing that people found is it was overkill for just about every application you could think of. It was made up of these. Does everyone actually know a little bit about Active Directory and directory services? Basically, think of them as an address book. All right, so this is what we're framing it as. It's a way of storing information, not like a standard database, but specifically for directories, obviously. But by that I mean things like phone book, you can keep your passwords in there, you can have links to resources, etc. It makes management of a system much easier because you can centralise the attributes for all of the systems and users that you have on your network. Okay, so X500, really big set of protocols, did everything that it could possibly think of doing, but was overkill for most applications, particularly when you look at user management. It was also based on the OSI network stack. Now, that is something we haven't covered yet. Who knows about OSI and TCP/IP stacks? Good. No one else does, so we'll just really quickly run through it. We'll cover this stuff later on. Okay, basically we have protocol stacks. Everything we do in this field has a stack of some kind. And the main one we use is, doesn't actually have this, is TCP/IP. Now we all know about TCP/IP. Right? We have a physical layer, data link layer, IP layer, and transport. Sitting above there is applications which we don't talk about too much. TCP/IP layer doesn't actually define the physical layer, but we'll treat it as if it does. Physical layer is the electrical signals, the cable connector, the way you modulate your signal to send it down a wire or wirelessly or through fibre optic or via carrier pigeon, whatever you want to do. Data link layer is the physical addressing. So every machine, you've all seen a MAC address on your machine, media access control address. It's a number that is hardwired into your computer which you cannot change. You can, but you can't. You shouldn't. Right? If you do change it, you can really mess up systems. But it's a hardware address. So every machine has this unique 48-bit number. Right? And that's used for local delivery. So when you're working in a local area network, like the machines in here, that's how the information is delivered, by this MAC address. Okay. That's really good, except when we look at something as big as the internet, it would mean that every single machine would have to know the number of every other single machine, which is a really big list and would take forever to search through and it's very hard to manage. So we have the IP layer. Now everyone knows IP addresses, IP version 4, 32-bit number, 134.7.56.56, fairly common thing. And it's a logical address. We're still using IP version 4, even though we've run out of numbers in IP version 4, but it's still there and it's still the main one we use. And it's a logical address in that we set it up so that it's hierarchical. So if we look at our example here, everything at Curtin is 134.7, which is a Class B address. So if you see a number that starts with 134.7, you know you send it off to Curtin. And then Curtin can look at how to actually get the local delivery from cutting those IP addresses down into smaller chunks, which we won't go into yet. All right, and then we have the transport layer, which is the end-to-end connection. This is how your applications connect. So when you've got a web browser open, right, it makes a connection to the web server. Which tab is it using? Which tab belongs to each site you're connected to? That is handled by the connections that are set up in the transport layer. And the transport layer works on ports. So port 80, for example, is a well-known port for HTTP. So when you go off and you want to talk to a web server somewhere, you're talking to its IP address and that port address for that web server. So it'll be 134.7.56.56:80, meaning it's the IP address of that machine. Port 80 connects it out to the application layer as a web service using the HTTP protocol, which is, that's what it says, hypertext transfer protocol. Okay, and then the application layer talks out to your application. So that's the interface between the network connection and your application. It doesn't have an FTP server in there, it doesn't have an FTP client or a web browser or anything else. It just defines how you talk to your application. The reason we do this layered system is when we make changes, we don't have to change the entire thing. In the good old days, everything was written for the network communication in one big program, because that's all these are, just a list of programs, set of programs. And if you change one thing, you had to change the entire program. If we want to change something in these layered protocols, all we do is we change the layer that is specific for that. So if we want to change from 100 gig Ethernet to gig Ethernet, all we do is we change the physical layer and the rest remains the same. If we want to add a new protocol in for connections, right, then we just change something in the transport layer and everything else remains the same. So that's why we have these layered protocols. Who knows the difference between, except for you, because you're going to put your hand up again, aren't you? Who knows the difference between IP version 6 and IP version 4 apart from 2? No?
So IP6
has
numbers?
Yep, 128 bits. It also handles things very, very differently, and we'll cover that in data comms next semester. IP version 6 is really important now because of the Internet of Things, where we estimate there's going to be 50 billion things connected to the Internet within the next 3 years. 2020 is the estimate. So that's an awful lot of things per person. All right, so we need more numbers. Is the main driving force for it, but it works very differently as well in the way it routes and is numbered. We also can't remember them because it's too long. So that's interesting. Okay, so this is the TCP layer, TCP model. There's also the OSI model, which is 7 layers instead of the 4 that's in the TCP IP. It actually defines the physical layer as well, but basically everything maps. Data link layer, network layer, and transport layer are pretty much the same. And the top 3 layers, session, presentation, and application layers, are actually all condensed into the application layer in the TCP. But they are different. And that is one of the problems we have with X500. It actually works on that 7-layer model, which has not implemented any real protocols. TCP IP isn't just TCP IP, it's a whole suite of protocols. Right? We just call it TCP IP because they're the 2 most common. So if you look at the back layer, there's a whole heap of those. You've got wireless, cabled, as in cabled Ethernet, token ring, dozens of others. If you look at IP, we used to have IPX, that's dead now. We used to have DECtalk, which is also dead. So for a long time, we only had IP version 4 that ran in the network layer. Now we've got IP version 4 and IP version 6. Transport layer, there's TCP, which is the common one, and there's UDP, RTP, and hundreds of others, SNMP, not SNMP, that's the application. But there's a lot of different connection type protocols in there. So, the OSI model, there isn't actually any protocols that use the OSI model that are in common use. So that's a reason, again, we can't use the use X500. So LDAP was created as a front end to X500. X500, as I said, is a very heavy, complex protocol to use, does everything you could possibly want, and in fact you don't need most of it. So rather than implementing the full X500 directory protocol on each of your servers and clients, University of Michigan, I think it was, somewhere there. Yeah, University of Michigan developed a front end to it, which was called LDAP, Lightweight Directory Access Protocol, and it's exactly that. It's the same thing, directory access protocol that allows us to have our address books and other information stored, but it's only what we actually need for these directories. So nice and lightweight. So that's about it from there. All right, this meant it was nice and easy to deploy. It's used everywhere, and it started to get picked up by everyone. And is now very, very common, and it's in actual fact how the underlying stuff in Active Directory works. It's still working in LDAP. You can integrate LDAP directly into Active Directory, and you can have Active Directory talking to LDAP as well. So they are similar. As I said, it's a directory service described in a couple of RFCs, who's read RFCs? Nobody's read an RFC. If you ever need a good bedtime story, read an RFC. It'll put you straight to sleep. There are requests for comment. This is how any changes on the internet are actually developed and propagated out to people who will use it. Requests for comment, meaning that people can actually provide feedback. They go through several stages and eventually either get adopted or trashed. And IETF, Internet Technology Task Force, Internet something Task Force, IETF anyway, they are actually in charge of those and they're worth having a read on. In fact, I suggest you have a look at a couple of these just to get an idea of what's in them, how they specify things, and will give you a much better understanding of the underlying technologies. And they're living documents, they keep changing too. So well, when they change, the number changes, but they keep getting improved on. Right, LDAP stores attribute data. Unlike most databases that store data themselves, LDAP and directory services store attributes, so things about an object. Right, so a username, right, which is about the user, and it's an attribute for that user. Your home directory that you're working in, which is the attribute of that user. Your passwords, etc. So they're a little bit different. Generally, it's a read-only type database, or it's far more focused on read. We don't change usernames, passwords, home directories, applications that often. We do change them. We have to change our passwords too often in many cases. But it's optimized for read rather than write. So you don't want to use LDAP for anything it's not meant to be used for. It has several disadvantages. It doesn't work on transactions, and anyone who's doing the database systems, you know what transactions are, which means you don't have a rollback. So if something goes wrong, you can have data corruption. It's not there because it doesn't happen very often. You can have conflicts. So if you have two people writing to a server, you don't know which one's actually going to be successful, which one will be retained, usually the last one, but not necessarily. So again, it's not good to use LDAP to store any form of real data, especially when you're doing lots of writes. Right, and as I said, you can't do rollbacks. It's based again on the client-server model, so you will have an LDAP server, which you will no doubt configure in one of the labs if you haven't done it already. Done LDAP in the lab yet? No, it's coming up. Yeah, it's coming up soon. It's really, really easy to set up. It's quite easy to populate and quite easy to integrate into a system, which is why people use it. As I said, it's based on a collection of attributes, and these attributes have a very structured way of being named. Right, and that's within our distinguished name, which is something like a domain name. Now, I think I've got a link I'll bring up later. Did Naz cover the DNS stuff when I was away? Not last week, week before? Sort of covered how DNS works. No? Okay, we can quickly look at it. DNS is domain name service, right? This is how we turn our IP address 134.7.56.56, which was deco.ece.curtin.edu.au. So here I am, I'm acting as a DNS server, and that's exactly what it does. It takes a name that people are used to and people can work with, and it turns it into the IP address that the network can actually handle. Okay, and it's a very simple sort of directory service database. As a simple file, which I've got an example of somewhere around here, which we'll get to. Text-based file, which you put in and edit to point names to IP addresses. And that's a name service. So it works on a very similar way. So when we look at an URL, a web address, we have it in a very, very structured format. And you have domains that you register. Everyone's got a registered domain name themselves. Should have. Great fun to have. Neat sheet. Right? Domain name.
What were you asking?
Have you got one?
I used to have.
Yeah. No, good. You know, get one in your own name. So I don't have one in my own name, but I've got lots of them in other little organisational names. But they're very structured. So if you read them, if we do www.ecu.curtin.edu.au, what's the first thing that you see there? Come on, I just said it. What's the first thing you see? No, leave that off. That's just the protocol. HTTP:// is naming the protocol you're using in this communication. So you can actually go FTP // whatever, and it'll try and connect to the FTP server. So that's naming the protocol you're using. the first thing you should look at is at the other end, AU, right? Because it works in a structured hierarchical manner. So when you have this URL that you type in, it sends off a query to the DNS server and says, who has this IP address? The DNS server then says it's an AU address, so it's somewhere in Australia. So it then sends a query off to the Australian server that says, right, it's an AU, yeah, that's mine. What's the next bit? EDU. So it's an educational one. So it then sends a query off to the education service in these top level domains. TLDs, they are the actual term. It then says, right, well, we've got an edu.aus, so the edu DNS server says, which educational institution is it? Ah, it's Curtin. So I send the query off to Curtin. So now it's got the curtin.edu.au. Curtin's DNS servers then say, okay, who's got ECE? Sends it down to the ECE name server, right? And then from there, it'll look up the www server and return through that chain the IP address. And each of those servers then keep a copy of it, it's cached, and it doesn't have to go through that entire process again. Which is why, if you want to improve your search speed, set up a caching-only DNS server at home, which is really easy to do, and you can do it on a Raspberry Pi or something small, and you'll actually speed up your lookups if you're doing lots and lots of web queries. Okay, so that's the hierarchical stuff that we're all familiar with in DNS, domain name services. LDAP is the same, except it works, well, no, it works the same way around. Yeah. Okay, so entries are arranged in a hierarchical tree structure in the same way as we have with DNS. So at the top we have an OU COM, which I'll explain a bit further soon. Right, and the COM is what you would normally term the root level entry for LDAP. Right, so a nice hierarchical system. Okay, so directories are a very specialised database. We use them all the time. Well, we don't anymore. Don't have phone books. Anyone use a printed TV guide or a phone book? Or no, nobody does anymore. But they're the sort of things they are. Right, same sort of stuff. Normally they're static. All right, how often do you change your phone number? Usually not very often. So these are things that we want to store. We want to be able to read them quite often, but we're not necessarily going to change them. So we've got a different setup. Okay, so I've got an example of those directories up there. Finger DNS, NIS, which is another one you'll be setting up on the Linux machines here. NIS is a real challenge to set up. Shouldn't be, but it is. And that's basically a way of sharing home drives on a Unix Linux desktop system. Okay, and your Unix password file is another one, which is a very simple sort of directory. Change classes. Okay. Now, the reason we have this in a lot of cases is because we, probably not supposed to use this next one. Network operating system based directories, there's several different varieties. Generally nowadays we only really have LDAP and Active Directory, but there were quite a few others and they're still around, but they're not all that common. NDS is a big one, that's the Novell directory system. We used to run that here, but got rid of it for Active Directory. It's very good for extremely large organisations and scaled much better than Windows domains in the previous iteration. So before Active Directory there was the NT domains and they didn't scale very well at all. NDS did. And these are specifically developed to serve the needs of a network. So keeping attributes and the resources you need as associated with a network. And we'll see this when we look at briefly at applications. The application-specific directories, these are generally embedded within an application. So if we look at our student management system, that is a directory of students, but it is for a very specific purpose and it does store large amounts of data. It's not available to anything except our Student One system. So if you create one of these sort of databases from an application, it doesn't make any sense to any other application out there. Right? So when you set up your database in the database unit using MySQL, Labs working yet? Labs working yet in database?
I've done it.
Oh, you've done it. Okay. Yeah, probably anyway, different story. Yeah. What was I saying? Oh yeah. So when you write something in MySQL or some other standard sort of database, that data is not available to any other application except the one you've written that database for. LDAP, Active Directory, the information within them is open to other applications and is designed as such. So it's not designed to be accessed by a single application. So some of these application-specific type directories, Lotus Notes, which is still reasonably common, the Microsoft Exchange, which is your email, contacts, calendaring, bulky, horrible, clunky system. Don't like it. But there's nothing much better. There was Novell's GroupWise around for a long time as well, which is still used in a lot of government departments, again, because it scales very well. But that was a truly awful system to use, worse than Exchange. All right, but these are specifically for an application like calendaring, like contacts, etc. Now, they quite often, like Exchange, will integrate with LDAP, or it'll integrate with Active Directory, or usually it'll integrate through Active Directory to LDAP, rather than directly to LDAP. So you can actually have your address book called from the LDAP server and put into the Exchange, which is generally the normal way of doing things. We have purpose-specific directories, such as the DNS, which we talked about briefly, and then we have our general purpose standard-based directories, such as LDAP and X500. And these are the ones that you can access from basically any application you write to pull the data out of. So why do we use things like LDAP? There's this particular problem, and I'm going to change glasses, where if you think about a large installation, every time you create a new user or install a new application, you have to go into that directory for the application and add that user. Or if you get a new user, you've got to go into every single application directory and add that user in and give them the attributes that they need to be able to access that particular application, the resources they need for that application. The use of LDAP is to do that in one hit that you can then apply to any user. This is why we use things like groups in Linux. It's a more primitive way of doing things, but it's a similar concept. If we set up a group of, I think something, a word processing package users, right? They need to be able to access the executables for the word processor. They need to be able to access the libraries, the dictionaries, and all those sort of things. We have to add that for that user. Another user comes along, we have to go through and add each of those individual attributes to that new user. If we create a word processor users group, we can then just apply that group or add that user to that group, and he then gets all of the things that they need in one hit for using the word processor. Okay, so that's why we have groups. And you can do that through LDAP as well, which is a better way of doing it. So this is why we actually use the LDAP. We can also distribute the management of the data to the appropriate people. Because it's a distributed system, we can put out LDAP servers and have them maintained by each of the areas that are looking after those users or those applications. So we can distribute out our workload to people at the coalface or close to where they need to be and have it managed locally, which is usually more efficient. Okay, it allows users to find the data that they need because we have a directory system. We can actually call things up, pull back our address book, and any of the attributes we want there. We'll look at what rights you've got, look at the services that you have access to. Importantly, we can distribute the servers out, right? So not only are we distributing the management out, but we can physically put the servers out in the areas where they're required. These services, these calls to the to LDAP, they're actually fairly heavy on the reading, right? So every time you want to do something, you open an application, it goes and allocates the drives or the resources you need, the shared libraries, the executables, etc., which may be cloud-based or in the server system. And it'll do that every time you start something or do something different, which generates a lot of traffic. Right? It has to go through multiple switches and routers, therefore you've got delays. If you have the server residing where it's actually used, so you have a replicated server of the users in that particular building, it only has to go to that building to do its queries. It also adds redundancy so that if something fails, the server in this building collapses, you can then go and move further up the chain, look at one of the other servers. So you can actually have a more reliable system. And of course, LDAP is a standard, therefore you can access it via whatever means you like. You can modify it. A good example of that was in the days when bandwidth was very expensive and the school was almost going broke with students downloading movies and things, and we actually had to pay for all that. We needed to have some form of quota system put on the network traffic. So we wrote here a little system using LDAP to go and query the at that time the NDS services, call it Active Directory if you like, get that username, authenticate that user, pull down their student ID, and then watch the traffic and keep a tally of the amount of traffic that they generated and pose a quota, so that if they went over their quota, we could disconnect them and stop them accessing anything further. And that was just an extension of LDAP. So using an LDAP server to talk to the Active Directory server, we could implement a quota system on the students so that they didn't download gigabytes of data and cost us a fortune. Right, so it's nice and easy to extend LDAP out to other applications, and you can share that data. We were using, in this case it was NDS, but it could have been Active Directory, could have been another LDAP server, to get the details and the rights of the student, get that information down to our LDAP server, perform some function, and maintain the school's costs. All right, so very good for the sharing of data. Okay, so what can LDAP do? It can find things like names and addresses in a phone book. There's a lot of other directories around that still exist but don't get a great deal of use anymore. Very good at managing things, and this is what I've been alluding to the whole time, is it'll manage your users. And it's a very, very good way of setting up the attributes for users rather than having individual groups. You can do that through LDAP, and it makes it easier to change and update. Yeah, you could use it for bookmarks in a web browser or even in other applications and small bits of data. And also can be used for storing passwords. So if you want to create your own password storage utility, one way of doing it would be through LDAP. So you remember your LDAP password, and we'll go through the authentication later. It would then connect to the LDAP server. You'd query it for the password for a particular application. It could then feed the application with that password, and you don't have to remember it. So it's very good at those sort of things, and keeping certificates, which are also quite difficult to manage manually, well, impossible to manage manually. Okay, what it can't do, it's not a relational database, so we can't do any rollbacks. There's the possibility of conflicts. If things fail, you can end up with a corrupt LDAP database. It doesn't do any file locking. File locking is simply, if somebody is writing to a file, it's locked for writes for everyone else. LDAP doesn't have any resource to do that, so two people can attempt to write to an LDAP record at the same time, which is not good. It can't search blobs of data. That's, for example, an image within a database. You can't search any large chunks of data on it. It has no query language, so if you've done SQL or MySQL type languages, you know that you query a database using a structured language. Select something from this table with these attributes. There is no way of doing that within LDAP. What is this here? Okay. No generic SQL language, and it is utterly useless if you don't write an application to talk to it. Right? It just sits there. You need to have an application to talk to it. Whereas a database such as MySQL, by using something like SQL, you can get it to perform useful functions without having a separate application for it. Okay, comparing LDAP to databases, LDAP is definitely read orientated and it's optimized for read. It's an extensible schema, so you can alter and change this to suit what you want to do. It has certain limited range of objects that you can select, but they can be extended, has inheritance, etc. We can distribute it. It has replication, so we can build in replicas of the LDAP database for reliability, speed, backup, etc. Right, so we can replicate it in other areas. Okay, so they're the main things there. Additionally, databases generally have complex relationships, so when you start to play around with the tables and the relations between tables and the keys, they become quite complex, which is why we have a unit in database design. It's more to database and design than just creating a list of objects to go in it and having an index. LDAP doesn't have any anything similar to that. There's no complex design, no interrelating tables. Purely a transaction model, so LDAP transactions are very simple. You either read an attribute or you write an attribute. There's really not much else you do there. It's defined for small bits of information. As I said, it's a directory service, so it's going to give you back things like a password, a phone number, a room number, and it doesn't do things like large images or other generic database type stuff. Okay, and finally, LDAP stores everything as attributes. LDAP is also hierarchical, as we've mentioned, very similar to the DNS system, so it has a hierarchical nature, and that's how we search through it, which gives us our scope for searching, which we'll have a look at in a sec. Standards are very important because the directories such as this, an Active Directory, NDS, and all the rest of them, have to be accessed by other applications. Right? You don't write the application directly for the database itself. Right? You expect other people to have applications which need to talk to it. It's there for data exchange, to share data, to share access to the environment that you're working in, etc. So it has to have standards in place so everyone knows how to read and write to it. Okay. All right, generally there's two types of directory services. We have standalone LDAP servers, where LDAP is the only access mechanism. So these are ones that you would set up, for example, as a phone book. So you just have a single application which talks to it and sends back the phone book. We have gateway servers which are used in the replication and convergence of information, and it could also be a gateway to other protocols. So if you were running X500, which a few places do, it's used a fair bit still in the communications field, not digital communication or data communications, but general telecoms, like the phone system, cellular phones, radio, etc. Important thing with LDAP is it doesn't really matter where the data is stored, because you can query it from wherever you happen to be. So, common applications, I mentioned a few of these before. White pages. White pages is a generic term for any form of directory for personal information or personnel information. Very good for authentication. So if you're setting up a remote login type system, LDAP is a very good way of doing that. I think that's what you actually do in the, what do you do? You'll either do some authentication stuff in the lab, or you'll set up a small address book. Right, so one of those two. One of the nice ones is roaming profiles. You can actually set up under your Linux or Windows system, if it doesn't have, or you don't have access to the Active Directory, you can set up a roaming profile so that when you go to a different machine in this room, for example, you log in, you get your environment set up, so your desktop wallpaper, your selection of icons, home drive, etc. So handy for that. Public key or certificate infrastructure, they're really long strings of numbers. You can use LDAP to store those, and you'll call them as and when you need it. So if you're using a PGP type key on your email, does anyone do that? Encrypt your email all the time, or you put a PGP signature on it? No, I worry about people that do that. They've either got something to hide or they're absolutely paranoid. Belong to the tinfoil hat brigade. But you can do that, and when you create an email, you can get the LDAP server then to provide the key for it, to do the encryption, and then send your email off, and then nobody will bother reading it because why bother? All right, and also for message delivery. There's a few different models available. Information model, which defines the data and the basic units of information within the directory. There's a naming model, and this is important because it's actually how you name everything within the schema. A functional model of how it actually operates, and finally a security model for how you authenticate to it. I don't want to go through too much of that because we don't need to. You can read that later. There's just a single page, this LDAP models tutorial, which will actually run through that for you. It's just a very short tutorial that gives a further explanation of each of those models. But the main thing to remember is that we have this naming model, and that's what we're really going to be looking at. So the naming model, we have these terms. We have DN, which is your distinguished name, a bit like mine, Sir Ian Murray. Yeah, that's very distinguished. Distinguished name is the full name you have. We have a relative distinguished name. Don't laugh, I got a knighthood. I did. That's what my AM means. Isn't that nice? Yeah. Anyway, relative distinguished name is the name that you have relative to where you're sitting, and we'll see this in the hierarchy, right? DIT is the full tree, directory information tree. So this is the structure that we have. And then we have LDIF, which is a particular type of format, DSML, which is another markup language format, not used as much, and OID, which is your object identifier. Okay, so probably easier to see on one of the next ones. Okay, this is the DIP. So we have a tree structure here. For those of us not looking at the PowerPoint, it consists of a linked structure. So at the very top we have the COM, which links down to our DC, which is a container. In this case, we've got a Pi software. Under that, we have groupings of other containers. So these containers, remember, just a hierarchical. We have the owner. Under there, we have like subdirectories, but they're not directories, so don't get them mixed up. In this case, it'd be the company name. Under that, we have people, but it branches off and there's two. So you can see that we have, oh no, it's only one there, but we could have OU, sorry, down here, a sysadmin sitting under the people and a sysadmin sitting under the group. So we would have two containers with the same name, all right? But because the branch is split off and they are separate, they have a different distinguished name. All right, so when we go through and we name it, it will have a different name because it's got a different path. And when we have the distinguished name, it is describing the full path through this hierarchical structure. So in this case, we could have COM, or DC equals COM, DC equals Pi software, OU equals people, and then UID equals B Marshall. Right? And that is a line of text that is the descriptor or the distinguished name. The relative distinguished name, if we were sitting at this level, would be OU equals people, UID equals B Marshall. Right? So it's talking about a relative distinguished name from the level that you're sitting at. So it's relative to the level that you're actually looking at. Okay, these are actually defined in that RFC, 2253. It uses a UTF-8 string representation, which means it's easily readable. This is just a standard ASCII type character. It's built up from the bottom rather than the top. Right, so when you're writing it out, you have the B Marshall, UID B Marshall would be the first entry, followed by the, what was it, OU people, I think it was. Yeah. And then go back up. Okay, two parts. The left part is called the relative distinguished name, and the right remainder is the base distinguished name. So there's the example. We have a UID of equal B Marshall, comma, OU equals people, comma, DC equals Pi software, comma, DC equals COM. And that describes in full the path you would take to get to that entry. All right, so when we're looking at a user, we would have within this UID, there's a set of attributes which might be, say, the user's password. And if you wanted to get that password, you would address it by using that fully qualified UID, B Marshall, comma, OU people, etc. If you use a relative distinguished name, it can be confused if there are multiple entries of the same. So you have to be aware of at what point in the LDAP database you are sitting at when you use relative distinguished names. Okay. There's the one I wanted. So the next one actually shows an example where we have two UIDs that are the same, or sorry, same RDN in this case, and we have the DC COM sitting at the top. From there, it splits into two, which is Pi software, DC equals Pi software, and DC equals Sun. From each of those, we have another set of UIDs that come off the bottom, and we have, sorry, OUs. One in the Pi software DC that's called people, and one in the DC equals Sun, OU people as well. But they are different, and we can specify them as being different because of that distinguished name. Right, so our entries, as I said, are composed of attributes, and they have one or more value, which we'll actually have a look at shortly. It has a value and it has a type. The type describes what the information is, and there's a set series of things for these, but you can extend it. The value is the actual information in text format, and these attributes have a particular syntax, which we'll look at in the schema. We all know what a schema is. It's a person who makes plans sneakily. No sense of humour. Schema is a set of rules, all right? Just a set of rules that state how the structure is set up and what kind of data is stored. So the schema in our LDAP is generally to do with users or user attributes. and is defined as such. It helps maintain a consistency and quality of data. I don't like that next one. Officially, it reduces the duplication of data, but it doesn't necessarily reduce the duplication because we can have those duplicate DCs and over UIDs, etc., because of the structure. So it is possible to duplicate data, but the schema should avoid that. Okay, object class, that's an attribute that each entry must follow. We're aware what object inheritance is from our wonderful object-oriented programming courses. You inherit the parent's attributes, and then you can add your own into the child object. Okay, it has inheritance as well. So when you create an object, a container, right, for a company, and you create another one under it, it gets all of the attributes of that container above, it inherits them through, right, and then you add some others onto it. So it inherits those attributes. So it's an object-oriented system as well. The schema contains required attributes. This is the things that you must have in there. So, for instance, a UID must have a name. It has a list of allowed attributes. These are the ones that you can add but don't necessarily have to have in there. There's a set of schema for how you can compare these attributes. And again, it's along the same lines as you would have in any programming type language. We have the compares, which we look at. I've got a list of shortly. We can limit the attributes, right? So we can have it so that it only contains an integer, ASCII characters only, or alphabetical characters only, and you can also reduce the duplication. Okay, object class is a top level one. It's used to group information. Basically has those things. And I am reading a lot of this, so Sindel gets it. Provides the following rules: required attributes, allowed attributes, and is the way that you retrieve the information. So this we get from the object class. Entries can have multiple object classes, so that gets a little confusing, but we can have multiple object classes. Yeah. As I said, these are inherited, they're derived from others. It extends the attributes of other object classes. Luckily, there is no multiple inheritance. That's something that, anyone program in C++? Don't do that. It's evil language. I know, it's common language, but C++ allows multiple inheritance, and that is always messy. It allows it to inherit the attributes of two separate objects. Yeah, messy. All right, but there is no multiple inheritance in LDAP. When you set the rules, you can't override them. All right, so once the rules are in place, they can't be overridden. Normally, under OO stuff, you can override methods. Yes, right, that's good fun too. Not a good practice, I don't think, but you can, but you can't in LDAP. Okay, there's only one required attribute, and that's object class, so you've got to say what the object is, and that's all that's actually required, and generally that's what our containers have. Okay, attributes. Attributes have a name, obviously. We need a unique identifier to be able to get to them. Not case sensitive, unlike most things in Linux and Unix. Object identifier is a dotted sequence of integers. No, we won't use that. Yeah. Okay, and we can actually say what they're storing, integer strings, etc. All right, so all of the attribute abbreviations are available here. Some of them are just listed underneath: UID, user ID, CN as common name, SN as surname, L location, organisational unit OU, organisation is O, DC is domain component, ST estate, C is country. But here we go. No, don't do that. Why didn't you do the link? That's not going to let me do the link. Have a look at that RFC. It's probably a useful one to look at. It's nice and short. Yeah, have a look at it. All right, and that will define the actual names that you can have, or the classes you can have. Right, so when we start setting this up, we want to set up replication, because we like replication. Replication means things can be reliable. If something breaks down, everything doesn't fall apart. It increases the availability. If we have more than one place to go and look for things, we don't have to queue up and wait for it. And remember, if you're looking at large organisation usage, if you've got several thousand people within the organisation, you will always have someone trying to read the information on your Active Directory or LDAP server. So we want to replicate it for efficiency, speed up responses. So that's why we do it. With replication, there's a few things we keep in mind. Inconsistencies are okay. Things don't have to be the same all the time immediately, as long as they converge back to what we want eventually. If we look at the way routing works, the routers that connect everyone together, they contain kind of database, the routing tables. Okay, and when you power everything on, do you get to connect out straight away to wherever you like? No, it takes time to converge. So these databases have to exchange information to make sure they're all thinking the same way and they have the same entries, etc. It takes time, it's expected, we can live with that. It's the same here. We don't have to have everything the same all the time. As long as it converges eventually or within a bounded time, a known time, it will do fine. Having this replication removes that single point of failure. But there's lots of ways we can do this. We can set it up like this, which is modifications to master. And here we have our LDAP client, which can talk to two servers. It sends its searches to the LDAP slave, which is a read-only, no changes can be made there. If we do an update, we send that directly to the master. The master then, at some point in the future, updates the slave. So you can see quite obviously that if we do a modification to the master and then somebody queries the slave, it may not be the updated information until some later point in time. But as I said, we can live with that in most cases. All right, that's a very simple way of doing things. It works quite well, but if your master falls over, you can't do updates. But if it doesn't fall over, if the master falls over, you can read the slave. If the slave falls over, then you can then fall back to using the master as a read as well. Right, so it will protect you from failure. Referrals is another way of doing it. Here again, we have our LDAP client and two servers, master and slave. When you send a modification to the replica, so you're only dealing with a replica, the replica will then returns the referral to the master client, right, saying I don't accept changes, I'm read only. It then goes off to the master and does the change. The master then responds with the results to the client, and at some later date, the master will update the slave. Why would you use a system like that? Come on, talk to me. Somebody talk to me. I'm tired of talking. Well, they could happen immediately, but not necessarily. What you do is you have this local to the people that are using it, and only one master sitting in your central office. Right, so remember it's optimized for read, so you're going to use this 99% of the time. Occasionally, you'll go off to the master and do an update, right, and that can take a bit more time because it's an update, no hurry. Then you go back to using the local one, and eventually the master will update the slave. So it's nice for a decentralized system, have the master off in your head office, do all your queries on the local slave. When you have to do a change, you go directly to the master. And it means also that if we've got multiple slaves sitting around here, we only do the one update to the master, and the master can then send them out immediately to all slaves. Okay, there's a chainway, which I can't really see much point in, but here we have again the client and slave and master. The client is only connected to the slave. I don't know why we do this. You send a query to the slave then sends the update on to the master then responds to the slave, and the slave then sends the query back to the client, and at some later date, the master updates the slave. Reason we would use this, any guesses? It took me a moment to remember what it was. Why would you want to use this? Yes, Cindy. Not really, because if the slave fails, you've got no connection from the client, which is a good thing in some cases. I would suggest that the reason you would do this is security. Right? Yeah. If you're doing an update, you've got to authenticate to the slave. You cannot get direct access to the master. all communication and updates happen from the slave to the master, which is a trusted connection.
I think sometimes it's multiple slaves.
Yeah, but if you've got multiple slaves, they'll all be doing the same thing. They'll be talking to the master, client will be talking to that slave, then up to the master.
Yeah. So I think once they've crashed, then it's still fine.
Not in this case, because if we take that slave out of the link, we have no link from the client to the master.
No, but there's another slave somewhere.
Yes, but you might not be able to get to it because it may be on a separate network, so you might not have access to it. It's a different way of doing it for that. If you look back at that one, that's a better way of doing it. If you've got multiple, if we've got lots of slaves sitting down here, we can still talk to slaves down here. Whereas if you've only got the one connection through, the reason you would do that is to stop people getting to the master, and you may not have links off to the other slaves. Okay, replication. Generally, we would have a single master. This is the best way to do it because it's simple. All right, single server would rewrite, copy the data. All the replicas just have read only. So we keep one trusted source. We know it's the real source because remember we don't have file locking. So we don't know who got the last write. So if we only have one machine that can do it, or accept the writes, it will be reasonably well known it'll be okay unless you corrupt the data. Problem is, of course, we've got a single point of failure. Another way of doing it, which is actually quite good as well, is a floating master. And here you have a method of selecting who's going to be the master. So if the master does fall over, then you just have another one that takes over. If you look at the way the domain controllers within Windows work, they have a primary, secondary domain controller, and if the primary falls over, the secondary takes over as the primary. Right? When the primary comes back up again, it becomes a secondary. Right? So you have that ability to re-elect a master. Quite often there will be some form of election process that this is done by. When you do the Cisco stuff, you'll find in the spanning tree protocol, you use an election to select who is going to be the root bridge or the root switch. Yeah, and it can quite often just be because it's implementation dependent. Whoever built it or decides on the protocol decides how that works. And in the case of Cisco switches, they will use something like the MAC address. So the largest or smallest MAC address wins, and they become the master. But you can set up other things there, and it depends on your implementation, and you just select the server that's going to be master. Okay, we can have cascading replication, which works through a hub. So you send everything into a central hub. This can help with the load balancing if you've got lots of reads coming through and lots of writes. Also can help disperse the workload to local areas. Okay, another way of doing things, and you would only do this in a very, very big system, is fractional replication. This is where you would break up your schema into certain attributes and sets of attributes which you would maintain on separate servers. So, for example, you would have your directory structure, that's the wrong word to use, your file system structure residing on one LDAP server, users on another, certificates on another, right? And you would replicate only those attributes to those servers. But that can get complex. And the last one on this lot is multiple masters. When you have more than one writable copy, you've certainly increased your resilience to any failures, but then you brought in this idea that you don't know which of your masters actually has the correct or most up-to-date information. So it's very difficult to implement, gives you automatic failover, which is kind of important in a lot of cases, but it is complex to implement. Okay, so that's how we set up the physical topographical information for an LDAP server. Once we've got that information, it's sitting in a database. We can't read it, all right, because it's a binary form. So we need a couple of utilities to exchange information. And LDIF is the format that is used in LDAP. It's human readable format, so you can actually export out, and I've got an example coming up. those files. Very, very handy if you want to make bulk changes. So you've got a large LDAP system, you've changed the, okay, we'll use word processor again, even though it's a bad example. You've changed the word processor you're using, so you've got to change the home directory or the library directories for every user in the system. So rather than having to edit it manually through whatever application you're using to control your LDAP services, you can export the entire file, run a script over to make the changes that you like, and then re-import that text file back into LDAP. Something that's really nice and not too easy to do within Active Directory. You can, but it's not as easy. Okay, so human readable format, you'll do this within the lab. You can use templates for additions, all kinds of things. So export all the data out in text format using LDIF, then make your changes, then import it back into LDAP. It's a nice, easy way of doing things.
So it changes the record. When you do that, it changes the record in the LDAP.
Well, it's if you want to change it. If you export it all out and then import it straight back in, it won't change. But if you export it out and make changes and import it back in, you haven't changed. Right? And because it's in text format, you can write a nice bash or Perl or name a script language program to go through and do bulk changes on it, and then just import it straight back in.
Yeah.
Right? So it makes nice and easy. Okay, if something contains non-ASCII characters, it begins with a space, colon or less than, and is separated by double colons. So this is how, I think in the example I've got one there of a password. And we can also have URLs in there as well. So when you're doing the lab, you will export one of these, have a look at the information you get out, do some non-binary stuff in there as well. Okay, entries in LDAP are separated with a blank line. Continuous lines start with spaces, so that's how you tell if a line is together or not. And if you start deleting spaces or deleting blank lines, then you are going to mess up your LDAP database. I love the utilities for this, they've got great names. Utilities convert from database to LDIF and back again. Slapcat, meow, good one. Yep. And slapadd. All right, so slapcat takes the LDAP database, turns it into LDIF text format, and slapadd takes it back in again. Really, really simple to use. So, okay. Unfortunately, most non-LDAP servers don't know how to deal with this stuff. And that's what I wanted. So here is an example of an LDIF file. We can see that it's exactly as it says. The distinguished name is the top here with the UID, etc. Because there's a space in here, it's a same line, continues on, and that's how you tell. We've got our user ID, container name, object class and account. It's a POSIX account, which means it's most of it's POSIX compliant now. And here we can see some of the things that are in there. Our login shell is named here in one of the object classes, and that's the bash shell. We get our user ID stored in here. So this is really good if you're using different machines and you're moving around different Unix machines. You can set the same user ID and group ID numbers to a user if they log in using LDAP, which means that you don't have to change the group ID and user IDs on every single machine. Because remember, when you add a user, it just randomly generates a user ID for you. So if you create Bill Smith on that one and Bill Smith on that one, they will probably have two different user IDs. If you do it through LDAP, you can set Bill Smith will always get the user ID of 500. All right? And that means it's the same throughout, because when you start looking at your password file and group file, it all works on group ID numbers and user ID numbers. And it's nice if you can have them all the same. Okay, and there we go. There's an encrypted passwords being stored within the LDAP directory at the bottom there, inside curly braces. There is another format that you can use, DSML. It's not that common. It's XML. If anyone has used XML, yeah, it's fun, isn't it? XML is just an extensible markup language, which means you define what it's marking up. We all know HTML. Everyone can do HTML, can't they? I can't. I refuse to. Absolutely point blank. Hate HTML. Right. Hypertext markup language. You've got MathML, which is mathematics markup language. You've got all kinds of other markup languages. DSML is just another one which is used within directories. Well, that's what it is. It's a directory markup language. All right, so here we go. We've got all our data in. We've exported it out. We've made some changes. We've imported it back in. Now we want to find things. So we can filter on several attributes. When we're filtering, we have to be aware very carefully of the base and scope. Where are we searching? Remember in that tree chart, we had the CNs splitting off into other CNs and then down to UIDs, and the UIDs or the CNs could actually be the same name. So when we're looking at scope, we need to know where we're looking at so we know we actually get the right result back, not one from a different tree of the hierarchy we're looking at in the set. We can filter on the different criteria and the attributes that are returned. It's a prefix notation, and there's again a couple of RFCs you can read when you're really, really bored to find out what the standards responsible for the format of the strings are, which you shouldn't need to do, but they're there anyway. You can have a lot of fun with LDAP. So basic filter types are listed there. Simple, you can read them. I'm not going to read them all out, but they are the standard sort of stuff. Presence, is it there? Is it equal? Now remember, equal is literal equal, so it has to be exactly the same. Greater than or equal to. Approximate, that's a really good one. How does a computer work out approximate? I think I've got it on the next one. SoundX is a good one. SoundX is a utility that you can use to look at the phonetics of a spelling of a name, and it will try and match the phonetics to the attempted spelling. So that's how you get things like approximate. We have the joining filters. These are just your logical operators and, or, and not. Each of these work like this. Presence is a simple check for the presence of an attribute. So if you want to check to see if somebody has access to a home directory, you can just look for presence of home directory, or home, or whatever you want to look for. Equality, yep. Something is equal to, so you search for username equals Bill Smith. There's substring matching, and I don't want to read through all of these, it's rather pointless. You can read through them yourself and try them out during the lab. Anything really critical in there? Nope. Okay, that's what I want to show. Order matching, the greater than, less than. Yep, the approximate filter, you've got to set that up yourself. It doesn't actually come with anything approximate. Common one, as I said, if you're doing phone books, is to use SoundX, which looks at the phonetics of the way you've typed something in and tries to match that to the phonetics of the entries. So if you typed in Smith and it was actually Smythe, it would try and match those connections up. Okay, and it's extensive, as we said. And this is what I meant by the scope. This is our search scope. We have our base scope, which is limited to the current level you're in. So in this case, we have our hierarchy, which has our root node, if you like. It's not root, but still. Our top level node, that forks off into two other nodes, and each of those two nodes fork off into another two nodes down the chain. If we're residing at that top level and we do a base search, or scope, keep the scope as base, it will only look at that top level. If we're down in the second level, it will only look in that second level one that you're attached to at that point. We can do one level, which limits it to the immediate children, so that's the container that you're in and the ones that are contained within that container, and only the ones contained within that container. And then we can do a sub, which looks at the entire tree down. So from the point you're at, all the way down to the base of the tree. And of course, these trees are all upside down for symbol's sake. So you have the trunk at the top, one thing at the top, and then it forks down into the branches and leaves downwards. Okay, so remember the scope when you're trying to do your searches. Okay, so again, it's a client server. It's message orientated, so we're using something like the REST-based system. We have a just a read and write, really, that we can do. So we send messages into the server, and then you then get replies. You can issue multiple requests, so they just chain together, and you can get the replies through. There's 9 basic protocol operations, which I think I've got, yep, on the next slide. LDAP-17 is a new version and has extended control, but we won't worry about LDAP-17, we'll just use the base stuff. Okay, I don't think I've covered this. It uses a simplified version of basic encoding rules. This is a way of representing how data is transferred, and I'm not sure if I've got it here. If not, we'll cover it later on, but it basically means that you know that every field has a function, and rather than just say sending the number 37, right, so if I send you 37, do I send it as a 8-bit number, 16-bit number, 32-bit number, or do I send it as 2 characters, 3 and 7? And if I'm going to send it as 3 and 7, do I send 3 first or 7 first? Right, BER sets a way that you configure that, so it has a field stating, is this an integer? If it is an integer, is it low order first or high order first? If it's a character, what encoding of the characters am I using? And the length of the information I'm sending. So I know we cover BER somewhere, but not here. All right, so it's a standardized version of encoding. So the protocol operations, this is what we've got. We can send these messages. Search and compare for the interrogation, so we're looking for something. We have update operations. Again, these are just as fairly straightforward: add, delete, modify, or rename. And authentication and control operations. This is how we actually connect to it, and we have a look at that next. All right, so the way we do this is term bind, which is your authentication, unbind, and abandon. You shouldn't use abandon, but unbind is basically the log out. So the conversation goes a little like this. We have a client here talking to a server. The client sends out the open connection and tries to bind to the LDAP server. This would be done talking through a, and I wrote it down so I wouldn't forget. It sends the IP address and the port number for LDAP, which in this case is 389 by default. Remember how I said when you do HTTP on anything, it connects through and says, I want to connect to the web server because it has that port 80. That's a well-known address for web servers. That's how it knows it's coming in HTTP, because the port 80. All right. In this case, it comes through on another port which says this is for LDAP, and the application layer then hands that out to the LDAP application that you're running. Server sends back a result of the bind. Can be yes, you can send a query, or no, you can't. You're not authenticated. We then do a search operation, sends the results back down to the client. We then send an unbind operation from the client to the server. Right, so we could have kept sending as many requests as we like, and they're active and there's a connection there until we do the unbind, and then the server closes the connection. Speaking of connections in TCP, you know one of the very early ways of attacking servers? You heard of the three-way handshake in TCP? Yeah, so you send out a thing, I want to talk to you on this port. It says back to you, yeah, okay, I'll talk to you, and here are the parameters, and then you send something back saying, yes, I accept those parameters, now let's talk. Every time you send through that first SYN, the synchronize, the server will reserve a certain amount of resources to handle that connection. So, and it'll sit there and wait, and wait, and wait, and wait. So what happens if you send another one? You reserve more resources. What happens if you send another one? More resources. That was the old way of killing off machines. You would just send bucket loads of these first connection requests. The server would reserve all this memory, and if you were running into version 4, the machine would just fall over. Just run out of resources and blue screen on you. So, nice little way of doing things. In fact, when you do network engineering in third year, you get to do a little break and reboot the machine next to you from remotely. It's a nice little crack to do. It works on local area networks, can work on just about any Windows machine. Randomly reboot. We'll just give you the VC's IP address to do that too. Oh, kill that recording. All right, so there's the text on how it works doing the bind, so I'm not going to read that out. Importantly, there's 3 levels of authentication, and you want to use, well, at least 2 of these all the time, because if you're allowing only read access, you might not want to go through the full handshake and have an authenticated connection. Just allow anybody to go in and read and then get a reply. So if it's looking for a room number or something that's unimportant, you may allow these anonymous binds, and then we don't send a username or password. Setting up the username and password can also be difficult, so if you're not doing anything that's critical, then don't bother. Unauthenticated by username only, which is a reference bind, sort of defeats the purpose of either. Why have a username and then no password? It's all in plain text, probably not a clever idea. And then you have the authenticated, which is probably the best way to do things by habit. So where you send a username and password. You set up all of these in the slapd.conf file, standard sort of format. Where is it? Where's it located? I'll go there. No, you should know where it's located. I've told you all about directory locations. Where would the slapd.conf file be? You should know this, guys. In etc. It's a configuration file, so therefore it should reside in etc.
Yeah.
Have a look at the slapd.conf file, just a text file, and you can change those things if you like. Okay, so some conclusions on that. LDAP is simple yet very versatile. It has a great deal of uptake. It's a great thing to be using at home and in small businesses. I don't know if you've looked at the licensing cost of Active Directory, but boy is it expensive if you're running a smaller business. And if you can do everything that you want to do on LDAP, why not do it? Free, easy to handle, extensible, can do lots with it. But more importantly, from your perspective, because you don't know where you're going to go and work, if you can work with LDAP, you will understand how Active Directory works underneath. You'll understand how NDS works underneath. So very easy to go from LDAP to Active Directory, very hard to go from Active Directory to LDAP because of the point and click and everything's hidden from you. So it's worth learning. You can do lots of really interesting things with it at home. Yeah, etc. All right. So there, it's just the conclusions there. You can read yourself. All right, and there's a related RFCs. And as I said, you should start to look at the RFCs, and I might just bring that one up while I'm here. Actually, I've got it here somewhere. That's low res stuff. That's that little brief talk on naming models, etc., which we've sort of covered. But it's not that critical. You can have a read of that. And
So does it mean LDAP sits on the TCP IP layer in the app layer? Transmission layer?
yeah, it's in the application layer. Yeah. You find just about all of the protocols that you deal with from a human perspective sit in the application layer. So if we have a look at the application layer itself, it's made up of lots of little programs sitting here. And one of these is, say, HTTP, and that's number 80. Sitting under here, you've got your IP, so transport,
Yeah, it makes sense.
IP, and then the MAC layer is this one. So when some ones and zeros come in here, it's read off, and you look at that 48-bit number, right, the MAC address, and each machine says, is that my MAC address? And if it is, it takes it here and passes it to the IP layer. There's also a broadcast one, which is all ones. So FF, right? It's hexadecimal, 48 bits. And if it's a broadcast of all ones, then you read it anyway. But if the physical address comes in here and it's yours, matches that hardware address on the card, you pass it up to the IP address. You then look at the IP address, and if that's yours, then you pass it up to the transport layer. This is where things get a little bit more interesting on the user side. So it'll look at the transport layer and we'll have, say, port 80 within the header of the transport layer. It then takes that data and sends it up here, right? And then this HTTP knows to send it out to your web browser, which is your actual application that's running or whatever. Right? But there's no web browser in there. If it comes in with a 21, right, it'll send that off to FTP. I think it's 21 anyway. 21, 22? I can't remember. Yeah, okay. You learn all this and then you try and forget, it becomes a repressed memory. Yeah, and at each layer, what happens is you've got your data comes in. Right, so we do it from here. So if we've got something here, and this is coming from a web server, this will be your HTML file. Right? It's passed into the application layer. The application layer then takes that as data, never looks inside, and adds on an application layer header. Right? Which has the data that the application layer needs, things like your port, your protocol. Right? The transport layer then gets it, and it takes all of that, treats it all as data, and adds on a transport layer header. And that will have port numbers in it, along with sequence numbers, acknowledgements, depending if it's TCP or UDP, whatever. It then passes it down to here, and treats all of that as data again, and sticks on the IP layer, which is going to have your IP addresses and options and type of service and a few other things in it. Then gets down here and turns all that into data and sticks on the LLC header, which is not true, because it's actually in 2 layers. This one's there, the logical link control and then the media access control layers, so it's actually 2 layers in there. At the other end, it comes in and reads a MAC address, as I said. If it's my MAC address, it takes that data, passes it back up here, looks at the IP header. Is it my IP address? Yep, strips that off and passes it up to the transport layer, looks at the transport layer header, strips that off, says, right, that's a HTTP, passes on to the HTTP protocol in the application layer, strips all that junk off, and passes out the HTML to our browser. So lots and lots of overhead. You've all got Wireshark on these machines. It's worth doing a capture on the Ethernet port, go to a simple web page, and download that web page, stop your packet capture, and actually look at the format of the information that comes in. We do this bit in the data comms unit, and it's really interesting, and it shows you exactly how these things work. Right? So if you're interested in protocols and how networks hang together, playing around with Wireshark is a good thing, and you should be interested because of course you're doing. Same as RFC should be interesting to you because it's got to do with stuff you're doing. Now, got half an hour. I think we'll leave the Linux admin until next week. It's only fairly short, but if I started, it's not good to stop halfway through. So I'll try and fit the next 2 in together next week. All right, you can have a read through. It's all on permissions anyway, so. All right, so we'll stop early rather than starting the next one. All right, sometime in the next week, 2, maybe 3, hopefully not that long, we'll have a couple of guest speakers in. First guy is a data scientist from the Cisco Innovation Center, and he's going to talk about high performance computing and the network requirements that are in there, so it's quite interesting as a different sort of view on these masses of information that we're passing around. Things like the terabytes and petabytes of data we're getting from the square kilometre array. How do you actually transport it somewhere? How do you process it? What do you do with it? How do you store it? All those sort of issues. And the other guy is probably a bit more interesting directly. He's a multiple CCIE. So if you know the Cisco certifications at all, you start with the Cisco affiliate type stuff, then the Cisco associate CCNA, then the professional level like CCNA security, and then if you're really, really into this stuff, you become a CCIE, Cisco certified something engineer. And there's only a few hundred in the country, and this guy's got 3 of them, so he knows the certification, he works for Cisco, and he's going to talk a little bit about his pathway through those certifications and what he does at Cisco, what it's like working in the networking field at a very high level. So it'll be interesting from that. And he's a good guy.